Hey everyone, it's Connor, and welcome back to another video of Under the Microscope. Today we're going to look at instant coffee and how it breaks down with water. Now I've got some newspaper on the microscope slide here, and we're going to introduce a little bit of water. And you'll see it zip across the newspaper in just a moment. There we go. And the water makes the newspaper a little bit see-through, so you can see some of the ink on the other side, those kind of red dots. And then we're going to put a little granule of freeze-dried instant coffee, and we'll see what happens. Now, in the same way that the water moved across the newspaper very rapidly, water is also going to move into this granule of instant coffee. Now, the way that this works is through something called capillary action. So water, if you think about a molecule of water, which is H2O, or two hydrogen atoms stuck to one oxygen atom, they sort of act like little magnets. So the hydrogen atoms are a little bit positive, and the oxygen atoms are a little bit negative. So water likes to stick to itself and other things. And you'll have noticed this if you look at water, or rain I should say, trickling down a window. And you might notice how sometimes the rain kind of coalesces into these streams and the droplets of water run into each other. Well, when the water comes into contact with the newspaper or the coffee, the water likes to stick to the newspaper, which is cellulose. And when one water molecule or several move towards the newspaper to stick to it, because water is attracted to itself, remember that each water molecule is like a little magnet, that drags more water molecules along with it. So you get this very rapid diffusion of the water across the newspaper and also into the instant coffee. And right here we've got a slightly larger granule. And one other thing that you'll notice, you can't really see it here, but you will see it in a moment, is that you'll see lots of bubbles forming. Now if you drink coffee, you'll see often when you pour the water quickly, you'll see a kind of froth or slight foam on the top of your coffee. And that is for the most part carbon dioxide. And that's just a byproduct of when people roast coffee. You can just about see those little bubbles there forming. And what we might have to do here is add a little bit more water to the edge of the slide, just to get things going a little bit. So we'll do that now. There we go. So you can see more of those bubbles of carbon dioxide forming. And you can see everything kind of being dragged as the water slides off the left-hand side of the microscope slide. Now we're going to look at this one more time, but without newspaper. Now what I have here is another granule of instant coffee, and that kind of shiny orb that you see in the top right, that's a droplet of water, and this is on a glass microscope slide. And what I'm going to do is push this instant coffee into the droplet of water. Now this is going to be super quick, so keep an eye out. Ready for it? Here we go. Boom. There we go. Now I thought I'd show you this because those bubbles of carbon dioxide are really, really clear on the glass. And it's pretty surprising at just how much gas is still inside of the instant coffee, even after it's been processed. You'll see some movement there, and that's because when you're looking at things under a microscope, the water starts to evaporate off the slide, and that creates these currents in whatever you're looking at. I hope you enjoyed the video. If you did, leave a comment, and thanks for watching.